Let us prove binomial theorem. This is one of the big deal in mathematics, so we should do it. So what we're doing is this. We will find the Taylor series of this function, and this function looks like this. General A, instead of 1, A plus B, but then if I write B like that, and then this is a constant, so we cannot take a derivative, so we need an x. So why don't we replace this with b with x? I mean, you could have replaced a with x, right? But the book does it this way, so I'll just follow that way, okay? And all I have to do is find the Taylor series for this, centered at 0. So we'll say our usual, this is a0, a0. a1x plus a2x squared plus a3x cubed plus da da da. So far with me? Okay, then our usual scheme, we evaluate it at the center. So holding this thing becomes 0, so we have a to the m power, correct? And that is equal to a0, so that tells you a0 is equal to a to the m power, okay? This a and that a have nothing to do with each other, it's just constant a, and this is coefficient a, 0, 1, 2, 3. Okay, one down. Take a derivative, so the m comes to the front, and then you have a plus x to the m minus 1a. Say yes. Okay, and the other side is on autopilot, right? But on this take-home quiz, this is the only way you're supposed to do it. So a1 plus 2, a2x plus 3, a3x squared plus da da da. Good. Okay, then we plug in 0 again, our center, not necessarily 0, but center, and center happens to be 0. On the quiz, your center is not necessarily 0, okay? So be careful, somebody screws this up all the time. So we have m, and then this thing dies, so we have a to the m minus 1. Good. And the other side, you have a1, and everything else died. So that tells you a1 is equal to m times a to the m minus 1. So far with me? Okay. Now we move on. So f double prime now of x is equal to, that thing comes down, power rule, so m times m minus 1, and then we have a plus x to the m minus 2a. And the other side is equal to 2 factorial. By now we know a2 plus 3 times 2 a3x plus dot 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 a. How are we doing? Why is my handwriting getting smaller? So double prime of x is equal to m times m minus 1 times a to the m minus 2 power a. Say yes.
Yes, double prime to the 0.
Nice catch. Yes. Was trying to see if you're paying any attention. I forgot 2 factorial and nobody caught it. Good. So that tells you a2 is equal to m minus 1. You see what this is building up to, right? You know, your combination thingy is developing right there. You get it? Okay, maybe we'll do one more and hopefully you will see the pattern. F triple prime of x is equal to m minus 1, and m minus 2a. And then a plus x to the m minus 3 now. The other side becomes 3 factorial a3 plus 4, 3, 2, a4, x, and da da da. So f triple prime 0 is m minus 1, m minus 2, m minus 3. Did I forget to put m minus? Nope. I didn't forget anything. And then this is A. Oh, no parenthesis. It doesn't want to erase now. My computer doesn't. Okay. So this is A to the m minus 3. Good. And the other side is 3 factorial A3. So that tells you A3 is equal to m minus 1, m minus 2 over 3 factorial. So far, so good, right?
What about the a to the m minus 3?
And
what about the a to the m minus 3? And the a to the m minus 2 for the one before?
What are you talking about?
The a term, a to the m, whatever, and a to the m minus 2, and a to the m minus 3.
I forgot. Let's put them down. So this is, let's put it right here. A to the m minus 2, and this is a to the m minus 3. Correct? So far so good? Now, you notice this thingy is what we call combination. What? Okay, hold on a sec. So if we say combination m choose 3, does it look like that? Oh, okay. Back up. Can I say this is m? So first 3 terms, this is what's known as a permutation, the numerator. Well, let's just put it this way. M factorial over m minus 3 factorial. Is that what that numerator is? What do you say? Do you agree they are the same thing? You don't agree they are the same thing? Let's see. This is m times m minus 1 times m minus 2 times m minus 3, m minus 4, m minus 5 cancels all of these. Right? So this is what we are calling combination. M choose 3, isn't it? And that's easier pattern to see now, isn't it? Okay, so I'm gonna put them. I wish I had. Just put it here. I'll put it in different colors. So dot. Guess what? A to the, let's say, not n. What is a nice n? A to the n. Guess what that looks like? It'll be m minus 1, m minus 2, dot, right? What does it terminate on? M minus, you see this number is 3 here, that's 2 here. Is that an indicator? M minus n, like that. Do you see that? Over n factorial. Do you see it? And then of course I have to write a to the Let's move this thing. And then I have to have a to the, what is it, m minus n. Do you agree with this statement? Do you? Because this is 3, that's 3, so this is n, that's n. You know what I'm saying? And this is what we are calling combination m choose n. You get it? Of a to the m minus n. Okay, then.
It's okay.
Yes.
Sorry, can you explain the m minus n, that one?
Okay, let's try. when n was 3,
Yeah.
this 0 is from m minus 1, m minus 2. That is 2. That's 1 less than 3, isn't it?
Yeah.
So here, when this is n, this number should be 1 less than m minus 1 less than n. You know what I'm saying?
Yeah, but wouldn't this give you negative
Oh,
n?
yeah. No wonder you didn't get it. I screwed up. That's why. I mean, n minus 1 is what I wanted to say.
Oh, yeah, okay, yeah.
That makes more sense, right?
Yeah.
Okay. We good? And then the other obvious questions, because we know exactly how many, right? What the general term is. But the other obvious thing is, doesn't this go forever? No, it doesn't. Why doesn't it go forever? Because this is an mth degree polynomial to begin with. You know what I'm saying? So this will terminate if we go down this way, like the other dot, dot, dot. If we take m's derivative of x, it will become 0, wouldn't it? M's degree is like third degree polynomial. If you take triple prime, it becomes 0 now, doesn't it? So this is not an infinite series. This is a terminating series. You get it? It ends with m. It becomes 0. So far, so good. So far, so good. So what is am then? We still have to figure that out, right? What is am? Well, am is combination of m choose m, isn't it? So it's not really 0, right? Do you see that? Oh, wait. M's degree polynomial, if you take m derivative, does it become a 0? No, it doesn't. M plus 1 is where it becomes 0, correct? Yeah. That's when it becomes 0, because third degree polynomial, derivative, first derivative, 3x squared, second derivative, 6x, third derivative, 6, and the fourth derivative becomes 0, okay? And this is it, and let's just figure out what that is. This is 1, right? Do you see that? Because this is 1, and this is combination m choose m is 1. Do you all know that much? Do you want me to write it down for you? Okay, here's an example. Combination of, let's say, 5 choose 5. Let's see what that looks like, right? It looks like 5 factorial over 0 factorial over 5 factorial, doesn't it? And that's 1. You get it? Okay. So that is our terminating term, and after that, it becomes 0. Okay, so I think we got it. So we can write it down as our, therefore, a plus x to the m power is equal to a to the m plus m times a to the m minus 1 x to the first plus m times m minus 1 over 2 factorial, if you will, a to the m minus 2 x squared, and so on. You know what I'm saying? Maybe I'll just write one more term, m minus 1, m minus 2 over 3 factorial a, and then a to the m minus 3 x to the third power.
Mr. Kim.
Yes.
I think I heard you talk about it, but I still have a question. Don't you technically need a statement that m minus 1 is is less than or equal to m, which n needs to be less than or equal to m plus 1?
What are you talking about?
Like for a sub n, the term, what happens if n is greater than m?
N is not, m is greater than n.
No, like, yeah, so my question was, so can n never be greater than m? Is it
Yeah.
like a assumed statement at the beginning, or
Well, n
do we
goes to m.
yeah.
I still don't understand the question.
No, my question is, do you technically need a stop statement to, like, when n is about to pass m, do you
Yeah,
technically need a statement for it?
well, that's what this line is for.
Oh, okay.
Yeah, I'm gonna shove it down and then really make a statement. Just to make Josh happy. Oh no, that's screwed up. Hold on. Let me. Okay. Oh, there's my gardener again. It's not my gardener. It's not even my building. We don't have a lawn. It's a stupid condo. Ah, that guy. I hate that guy. Okay, here's a statement. So a m plus wrong color. A m plus 1 is equal to 0. Do you see that from here? And then f of m plus 2 of x is equal to 0, which tells you a m plus 2 is equal to 0, and so on forever. They are all 0 after that. You happy?
Wait, so it just stopped by itself, right?
Yeah.
Since after m plus 1 term, everything goes to 0.
That's the whole idea.
Oh, okay.
Right? The derivative just dies, and derivative of 0 will be forever 0. That's why this thing terminates by itself. It's not like
Yeah.
we're intervening. Even
Okay.
if you write a program and have it go up to 1,000 terms, it'll terminate after n.
Yeah, okay.
Right? Maybe I should write m's derivative here. You want me to?
I mean, I think it's fine.
Are you sure? Does anybody want it? M's derivative?
I'll also just write it then.
Yeah, let's write it just to prove a point, right? Let me push that over. So f of m's derivative, what would that look like, right? Okay, let's look at it. These things go down all the way, right? And it keeps going down, right? So I think it looks like this. M factorial, what do you say? A plus x to the 0 power. Do you see that? Because it keeps going down by 1. You know what I'm saying? This is third, and then it went down to m minus 2. So when it's m, it'll go down to m minus 1. Okay. And that's what, and it goes down to 1, is what I'm saying.
And that equals to a sub m, right?
Well, that's and then the other side looks like this. The other side is m factorial a
sub m, okay.
Right, and that terminates. There's no more x. Well, there is, but they are gonna die, so we don't care. How about that? Is that better?
Okay, so the last term is, wait, then wouldn't that make a sub m 1 then?
Yeah, this is 1. I said this is 1.
Oh, okay.
It's supposed to be 1.
Yeah, because I thought if you use like binomial theorem on like x plus 2, wouldn't the last term be 4 instead of 1?
No, it doesn't. Here's
Or x plus 2 squared.
I'm going to write down the last term here so you can see. That last term should be 1 times x to the m power, right? You see that?
Oh. Oh, like everything is flipped.
Yeah.
Oh, like, okay, that makes more sense.
This theorem tells you exactly what you're supposed to have. Let's put it in sigma notation now. So this will be sigma n starting from 0 to m, and combination m choose n, and then a to the m minus n x to the n power. You get it?
Yeah, okay. Because we're used to writing the highest x term in the front, so okay.
Yeah, but whenever we did Taylor series, we started with the constant and it goes up in a second.
Yeah, okay, yeah. That I think that's why I was really confused. Yeah, okay. I
And
understand.
in algebra 2, instead of x, now you put b here, and then this becomes b. Otherwise, it's exactly the same thing. You know what I'm saying? Oh, this is so satisfying proof now, isn't it? I mean, maybe we should write down that as well. A plus, that's ugly, A plus B. This is how you've seen it. You've seen this one as n, and but I think we'll just keep it, right? You know, that thing is binomial theorem as you remember it. And this is such a beautiful proof now, isn't it?